Hello everyone, welcome to my channel. In this video, we are going to learn MicroPython with Raspberry Pi Pico. Before we go into details, let's get to know about Pico. What's the difference between Pico and Raspberry Pi previous models? The one we have here is the Raspberry Pi 3 Model B. It is the third generation single-board computer launched in 2016. A newer version, the fourth generation, was launched 2 years back. These models are basically microprocessors. It can be used for general purpose computing. It runs Linux operating system just like a regular computer. It is equipped with Bluetooth, Wi-Fi, Ethernet connections, HDMI connections, as well as USB ports. It can be connected to various peripherals like monitor, keyboard, mouse, and other devices. Hence, these models are fairly expensive, which is more than $100. Pico, in the other hand, is a microcontroller unit or MCU. It has its own CPU, memory, as well as input and output ports. It is usually dedicated for a specific task. It has less computing power compared to Raspberry Pi 3 models or 4 models. That is why Pico price tag is actually fairly cheap. It costs less than $10. Pico was introduced in the early 2021. As a newcomer in the MCU world, the market is still being ruled by Arduino products as well as ESP family. As we can see from the video, from the most right, here we have ESP32 board, and then we have Pico, Arduino Nano, as well as Arduino Mega. Now, let's compare these four products. In the table here, we can actually see the comparison of this board in terms of their prices, number of cores, computational speeds, flash memory, and others. By far, Raspberry Pi Pico board has a quite good bargaining position among the others. It is the cheapest with excellent performance. RP2040 chip that is actually powering this board is a dual-core ARM Cortex chip. It has 133 MHz computational clock. It has also 2 MB of flash memory where you can store your programs. Additionally, the board has also an LED as well as temperature sensors. This board can be programmed using MicroPython, C++, as well as Arduino. Okay, so this is the development board of Raspberry Pi Pico. The one in the middle here is the RP2040 microchip, 32 bits. And then we have a small white push button for boot selection. And then we have also here is the USB micro B port. And then on the corner of there we have a small LED. We can use it for indicator. And then these are the pins. This is a pre-solder board. Yeah, these pins are mostly for input and outputs, but there are also some pins which are dedicated for a specific functionalities. Like we have a ground pins. We have pins for a 3.3 volts. Yeah, just to remind you that this board is 3.3 voltage level. So you might need to check at the back of this board regarding the pin numbers. Alright, so the next step is to download Thonny IDE for MicroPythons. There are several other IDEs that you can use to program MicroPythons, but in this project we will use Thonny IDE since it is recommended by Raspberry Pi. Okay, I suggest you to check on Raspberry Pi Pico website. There you will see a getting started with Raspberry Pi Pico webpage, in which is very useful if you want to start a project with Raspberry Pi Pico. Yeah, there is introductions over there containing how to, you can say, what you can do with this board basically. And then what are the pins available on this board is also written over there. Now the step that we are looking for is to install a Thonny IDE. So here you will see there, Thonny IDE. So there are two ways. If you have a Raspberry Pi operating system, Thonny IDE is already installed over there. But if you want to use Windows or Mac OS or Linux, so you may need to check on this page, to download Thonny IDE. So on this page, you can actually download these 3 versions. So the one that I'm using currently is the Windows laptop. So here I am downloading it. So now let's just install it, and then just follow the step of the installations. So you can click any one of these two. Alright, so let's just follow the step of the installations. Okay, so the next step is to set the Pico board as a bootloader to install the MicroPython in it. To do that, we need to have USB-A to micro-B type of cable, and then we need to connect the USB-A to our laptop or PC. Now we need to connect the micro USB-B cable onto the Pico board while pressing the boot cell button. This will set the Pico board entering the bootloader mode, such that we can install the MicroPython in it. Once the bootloader is set, the Pico board will act as a storage device, as you can see in your PC or laptop. Let's open this storage and double click the file in it. This file will guide you to a web page in which you can download MicroPython. Make sure that you connect your laptop or PC to internet. Now from this web page we can download UF2 MicroPython file. Once you download this file, what you need to do now is to just drag and drop this file into the storage that you opened before. So I will just drag this file into the storage. This will actually install the MicroPython inside your Pico board. Once this file is installed, now you can see that the mass storage is actually disappeared. Alright, so now we can open Thonny IDE, and then first thing first, we need to set up the Python interpreter inside this IDE. On the bottom right corner, you can check over there. Click on it and then make sure that you choose Raspberry Pi Pico, and then select the correct COM port for this board. If you don't know which COM port you need to choose, you can actually check from the device manager and then see which port that is used for your Pico board. You can see over there it is COM number 5. Now you can go back to the interpreter and then make sure that the COM port is correct. Okay, so now everything is ready. We just need to test them. Let's start with a mandatory test by printing hello world string. It is fairly simple. We can use print syntax to print characters or strings in MicroPython. Once you are done with the code, now we can save this file inside the computer or Raspberry Pi board. Now we will save it here in the Raspberry Pi board, and then don't forget to rename the file with extension of .py. Now we can click this green button to run the program. Now you will see here the results on the screen down there, and then we can stop the program. Now the next example is to control the onboard LED. LED or light emitting diode is an example of an output device. As we can see from this diagram, the arrow shows the direction of informations or data or signals. So in this case, if we want to access an LED, the MCU board, which is in this case the Pico board, need to send the signals to the LED. Or in other words, the signal is coming out from the MCU board. It has the same logic when you want to control servo motors or any kind of motors, speaker, lamps, and other output devices. For the input devices like push button and sensors, the direction of the information is in the opposite way. It means that the signals or data is actually coming from the input devices into the MCU board. So it is in the opposite direction. Okay, so now let's control the onboard LED. In order to do that, we need to know which pin that is used to control the LED. Yeah, so we can go to the website there and then click the Raspberry Pi menu, and then you will see that the pin that is connected to the LED is pin number 25. It's GPIO 25. So we can use this information to control the LED. Okay, so now let's start the coding part. Let's open Thonny IDE. Right, so this is Thonny IDE. If you don't see this untitled file, you can click File and then click New, or basically you can simply click these plus buttons. Yeah, so it'll give you a new file over there that you can work with your codes. Now I will compare this code with Arduino, since most of us most probably already familiar with Arduino. So let's see what's the difference between MicroPythons using Thonny and Arduino coding. Right, so first thing first, we need to import machine modules or library basically, and then secondly we need to import UTime containing the timing inside the Pico board later on. And then here I define an LED variables, LED pins, yeah, equal to machine.pins, which actually we need to mention the pin number, which in this case GPIO 25, and then we need to set this pin 25, yeah, as the outputs. That's why there you will see machine.pin.out. And then in Arduino you just need to use a define syntax. So here I define LED pin variable as number 25. Alright, and go back to the Thonny IDE. So here I initiate the value, or you can say the condition for the LED as a 0 or low. In this case means that the LED is off. And then for the Arduino, we need to set up first the pin numbers, the LED pins, in the void setup functions. So we set up here the mode of this LED pin as the outputs, and then we need to initiate the value for these particular pins as 0 or low. Means that the same logic, we turn off the LED at the beginning. Yeah, so you can write them as low or 0, it will be the same. And then we need to somehow create a looping function. So in Arduino it is already available there, void loops, but in the Thonny IDE is not available. So here we can create our own loops. So here I made a variable called loopcon as true. Yes, so and then I create here a while loops. Yeah, so while a loopcon means that while it is true, while this variable loopcon is true, so it will actually execute the code inside this particular while loops. And then first thing first, I will turn off the LED. So LED pin dot value, give them 1 or high, it will be on. And then utime dot sleep means that the elapsed time of these LED pin value equal to 1 will be 1 second. 1 means 1 second, and then I turn off afterward, yeah, for 1 second as well. So utime.sleep 1. Similarly for Arduino, it is also simple codes, yeah, inside this void loop. So first thing first, digital write, because we need to give these LED pins a particular high or low value, so we just need to use a digital write. So LED pins comma high or comma 1, it will be the same, and then delay for 1000, since the unit in this Arduino IDE is in millisecond for the delay, so I give them here 1000.
So the same thing for the low or turning off the LED. I give them also delay for 1 second. Now once we're done with this, so we can save this file, yes, inside the Raspberry Pi here. Okay, don't forget again, you need to make sure that the file name has the extension of .py. Okay, .py. So I already have several files over there, so I will give this file with, let's say, lednew.py, and then click OK. When you save this file, you can run them by clicking these buttons and then see the effect here in the LED. Okay, so this video shows the results of the code that we just made. It shows the LED blinking every 1 second, yeah, on and off every 1 second. Alright, so this is the end of the video. The next chapter we will talk about more devices and how to actually control them using a Raspberry Pi Pico. So don't forget to leave a like and comment below. Don't forget to subscribe to this channel. Thank you so much for your attention. Bye bye.